Hello everyone, and welcome to this in-depth lecture on the evolution of artificial intelligence. Today, we're going to embark on a journey spanning decades, exploring the fascinating milestones, breakthroughs, challenges, and philosophical debates that have shaped AI into what it is today. Whether you're a student, a professional, or just a curious mind, I invite you to sit back and enjoy this lecture as we dive deep into the evolution of one of the most transformative fields of our time. Let's begin our journey in the early days of computing. In the 1940s and 1950s, when computers were room-sized behemoths and the idea of machines thinking seemed like science fiction, pioneering figures such as Alan Turing began to ask fundamental questions. Turing's seminal work on computation and his famous Turing test laid the groundwork for understanding how machines might emulate human thought. His ideas raised questions not just about the mechanics of computation but about the nature of intelligence itself. Early computers, limited by hardware and algorithmic constraints, sparked the imagination of researchers who saw the potential for machines to solve complex problems, a potential that would eventually bloom into the field of artificial intelligence. As we moved into the 1950s and 1960s, the term artificial intelligence was officially coined, and optimism was high. Researchers like John McCarthy, Marvin Minsky, Alan Newell, and Herbert Simon envisioned a future where machines could perform tasks that required human intelligence. This period saw the development of early symbolic AI systems, where reasoning was encoded in formal logic. Programs like the logic theorist and the general problem solver were among the first attempts to replicate human problem solving in a computational framework. The field was characterized by a belief that if we could just formalize human reasoning, computers would soon rival or surpass human intellect. However, as the 1970s approached, the limitations of these early approaches became increasingly apparent. The initial promise of symbolic AI gave way to what many termed the AI winter, a period marked by reduced funding, skepticism, and the realization that encoding the complexity of human thought into rigid logical systems was far more challenging than originally anticipated. Researchers discovered that many aspects of human intelligence, such as perception, language understanding, and learning from unstructured data, were not easily reducible to simple rules and algorithms. Despite the setbacks, the lessons learned during these early years provided invaluable insights, leading to more refined approaches and setting the stage for future breakthroughs. Transitioning into the 1980s, the field saw a revival with the emergence of expert systems. These systems, which relied on vast rule-based frameworks to mimic the decision-making processes of human experts, found practical applications in industries such as medicine, finance, and engineering. Expert systems like milestones, designed for medical diagnosis, demonstrated that AI could deliver tangible benefits by assisting professionals in making complex decisions. Although these systems were highly specialized and lacked the adaptability of human cognition, they underscored the potential for AI to become a valuable tool in solving real-world problems. The successes and limitations of expert systems drove researchers to explore more adaptive models, ultimately paving the way for machine learning. The 1990s heralded a paradigm shift in AI research with the advent of machine learning. Instead of relying solely on pre-programmed rules, researchers began developing algorithms that allowed computers to learn from data. This marked a significant departure from earlier approaches, as it enabled systems to improve their performance over time without explicit reprogramming. One of the pivotal moments in this era was the development of statistical learning methods and the application of neural networks. Although early neural networks were relatively simple compared to today's standards, they ignited the spark that would eventually lead to the deep learning revolution. The progress in machine learning during the 1990s was bolstered by increased computational power, more sophisticated algorithms, and the availability of larger data sets, all of which contributed to a resurgence in AI research and development. Entering the 21st century, we witnessed an explosion in the capabilities of AI, largely driven by the convergence of big data, enhanced computational resources, and revolutionary breakthroughs in deep learning. Deep neural networks, with their many layers and complex architectures, began to outperform traditional machine learning models in tasks such as image and speech recognition, natural language processing, and game playing. One of the landmark achievements in this period was the development of convolutional neural networks, CNNs, for image analysis, which dramatically improved computer vision applications. Simultaneously, recurrent neural networks, RNNs, and their variants, such as long short-term memory, LSTM, networks, advanced our ability to process sequential data, leading to significant improvements in language translation, sentiment analysis, and time series forecasting. In the mid-2010s, the landscape of AI was irrevocably transformed by deep learning, a subset of machine learning that had its roots in neural network research. Breakthroughs such as AlexNet, which achieved unprecedented accuracy in image classification tasks, brought deep learning into the mainstream. Researchers and engineers around the world began to apply these techniques to a wide range of domains from autonomous vehicles and robotics to healthcare and finance. Deep learning's success was not just limited to improving existing applications, it also opened the door to entirely new possibilities, such as generative models. Techniques like generative adversarial networks, GANs, and variational autoencoders, VAEs, enabled machines to generate realistic images, music, and even human-like text, sparking debates about creativity and the nature of art. As AI technologies became more pervasive, discussions around ethics, accountability, and the societal impact of AI grew in prominence. With great power comes great responsibility, and the rapid evolution of AI prompted researchers, policymakers, and technologists to address issues related to bias, transparency, privacy, and fairness. Ethical AI has become a critical area of research, with initiatives aimed at ensuring that AI systems are developed and deployed in ways that respect human rights and contribute positively to society. These efforts include developing algorithms that are interpretable, designing fair data collection processes, and implementing robust governance frameworks to oversee AI deployment in sensitive areas such as law enforcement, healthcare, and finance. Another exciting frontier in AI evolution has been the integration of reinforcement learning with deep learning. Reinforcement learning, a framework where agents learn to make decisions by receiving rewards or penalties for their actions, has been combined with deep learning to create systems that can learn complex behaviors in dynamic environments. One of the most well-known successes of this approach is AlphaGo, the AI program developed by DeepMind that defeated human champions in the ancient game of Go, a feat that was long considered beyond the reach of machines. This breakthrough not only showcased the power of combining different AI paradigms but also demonstrated the potential for AI to tackle problems in domains previously thought to be the exclusive realm of human intuition and expertise. Parallel to these technical advancements, AI has also made significant strides in its practical applications. In the realm of natural language processing, for instance, the development of transformer-based architectures has revolutionized how machines understand and generate human language. Models like BERT, GPT, and their successors have set new benchmarks in tasks such as language translation, summarization, and conversational AI. These models are now powering virtual assistants, customer service bots, and a host of other applications that require sophisticated language understanding. Their ability to generate coherent and contextually relevant text has not only enhanced user experiences but has also opened up new avenues for creative expression and communication. As we continue our journey into the current state of AI, it's important to highlight the growing trend of interdisciplinary research. AI is no longer confined to computer science departments. It is now a fundamental component of research in fields as diverse as neuroscience, psychology, economics, and even philosophy. This interdisciplinary approach is fostering innovations that blur the lines between traditional academic disciplines, resulting in novel insights into how intelligence, both artificial and biological, can be understood, modeled, and replicated. Collaborative projects that bring together experts from different fields are exploring the frontiers of brain-computer interfaces, neuro-inspired computing, and even the ethical implications of creating machines that can mimic human consciousness. The future of AI holds both immense promise and significant challenges. On the one hand, we are witnessing the rapid development of technologies that have the potential to solve some of humanity's most pressing problems, from climate change to healthcare disparities. On the other hand, the increasing integration of AI into everyday life raises important questions about the nature of work, the distribution of power, and the potential for unintended consequences. As AI systems become more autonomous, ensuring their safety and aligning them with human values is paramount. Researchers are actively working on methods to imbue AI systems with a sense of ethical reasoning and to build robust frameworks for monitoring and controlling their behavior. This ongoing work is essential to ensure that as AI systems become more capable, they also become more aligned with the interests of society as a whole. Let's not overlook the significant role that hardware advancements have played in the evolution of AI. The development of specialized hardware, such as GPUs, graphics processing units, and TPUs, tensor processing units, has been instrumental in enabling the training of deep neural networks at scale. These advancements in computational power have allowed researchers to experiment with larger models and more complex architectures, thereby accelerating the pace of discovery and innovation in AI research. The synergy between hardware and algorithmic improvements has created a virtuous cycle, driving the field forward and opening up new possibilities that were once considered the stuff of science fiction. As we explore the evolution of AI, it's also essential to consider the impact of open-source communities and collaborative research. The democratization of AI research has been greatly facilitated by the widespread availability of open-source frameworks and libraries, such as TensorFlow, PyTorch, and Keras. These tools have lowered the barrier to entry for researchers and developers around the world, fostering an environment of rapid experimentation and shared learning. Open-source initiatives have not only accelerated innovation but have also encouraged transparency and reproducibility in AI research principles that are critical for the continued advancement of the field. Looking ahead, emerging trends in AI research are beginning to push the boundaries even further. One exciting area is the exploration of hybrid models that combine symbolic reasoning with neural networks. These models aim to leverage the strengths of both approaches, integrating the interpretability of symbolic methods with the adaptability of deep learning. Another promising direction is the development of AI systems that can learn continuously over time, adapting to new data and changing environments without the need for extensive retraining. Such systems would be capable of lifelong learning, much like humans, and could revolutionize the way we interact with technology. The societal implications of AI cannot be overstated. As AI systems become increasingly integrated into our daily lives, they are reshaping industries, economies, and even our social structures. From automating routine tasks to enabling entirely new forms of creative expression, AI is transforming the way we work, learn, and communicate. At the same time, this rapid transformation poses significant challenges, including the potential for job displacement, privacy concerns, and the ethical dilemmas associated with autonomous decision-making. Addressing these challenges requires a concerted effort from policymakers, industry leaders, and the global community to ensure that the benefits of AI are distributed equitably and that its risks are managed responsibly. Another dimension of the evolution of AI is the ongoing debate about the singularity, the hypothetical future point at which technological growth becomes uncontrollable and irreversible, resulting in unfathomable changes to human civilization. While opinions vary widely on the likelihood and timing of such an event, the very discussion underscores the profound impact that AI is expected to have on our future. The concept of the singularity challenges us to think critically about what it means to be human in an era where machines may eventually match or even surpass our intellectual capabilities. Whether one views the singularity as a cause for excitement or concern, it is a powerful reminder of the transformative potential of AI and the importance of steering its development in a responsible and ethical direction. Throughout this lecture, we've seen how AI has evolved from abstract theoretical concepts to practical, life-changing technologies that touch nearly every aspect of our lives. We've examined the early ideas of computation and intelligence, explored the rise and fall of symbolic AI, and followed the dramatic resurgence brought about by machine learning and deep learning. We've also considered the ethical, societal, and philosophical questions that arise as AI systems become more sophisticated and integrated into our world. Each phase of this evolution has built upon the lessons of the past, driving us toward a future that is both exciting and fraught with challenges. In conclusion, the evolution of artificial intelligence is not just a chronicle of technological achievements, it's a testament to human ingenuity, curiosity, and the relentless pursuit of understanding. As we stand at the crossroads of unprecedented technological progress, it's essential to remain mindful of both the opportunities and the responsibilities that come with creating machines that can think and learn. The journey of AI is ongoing, and the coming decades promise to be as transformative as those that have preceded them. I hope this lecture has provided you with a comprehensive understanding of how far we've come and the exciting road that lies ahead. If you enjoyed this deep dive into the evolution of artificial intelligence and want to stay updated with more insightful content like this, please make sure to hit the like button, leave your thoughts and questions in the comments, and most importantly, subscribe to our channel for more continuous lectures on technology, science, and innovation. Thank you for watching, and I look forward to exploring more fascinating topics with you in the future.